Okay, so we will now extend this discussion that we had with steady state heat generation, the formulas that we developed, and the discussion that we had, sort of informally extend that to thermoregulation. I say informally because thermoregulation is a lot more complex, and we are not really doing anything like that, but we can relate what we did a little bit to thermoregulation or the lack of it. So little bit about thermoregulation. Um, so there are two types of animals, warm-blooded and cold-blooded, and this is a picture from a textbook that shows how a reptile, a snake, for example, its temperature just continuously changes with ambient temperature. So it is not doing thermoregulation. So this is what we just did. Our analysis of conduction in a slab with heat generation inside. This predicted that the temperature inside is higher than the outside, but really this temperature, the maximum temperature inside, is related to the temperature at the boundary. So it keeps changing with temperature at the boundary. Remember, we had a formula like T max equal to T1 plus QL square over 2K, something like that. So maximum temperature, the core temperature, keeps changing with the surroundings. And so here we have a situation that is sort of close to that, where the core temperature keeps changing with the ambient temperature. But in case of the warm-blooded animal like humans, like in this case the bobcat, even though the ambient temperature changes, the core temperature stays more or less constant. So how does it do that? This is an active process. What we have been studying is passive diffusion with heat generation. That isn't going to give you this. Okay, so just a little bit of insight into what is done to make the process active. So let's say if the ambient temperature increases, then heat loss from our body surface is H times T of skin minus T infinity. So if T infinity keeps increasing, then this difference, the difference between them, keeps decreasing. So convective heat loss keeps decreasing. If the convective heat loss decreases, then but we are still producing the same amount of heat, then heat has to be released in some other way, and that's why then we start to sweat and the evaporative heat loss increases. Okay, so that's when the temperature increases. When the temperature decreases, using the same idea, HT skin minus T infinity, okay, then the convective heat loss keeps increasing. So to make up for that, then the body starts to shiver and produce more heat inside to keep the temperature constant. But this increasing heat generation, it cannot just keep increasing. So it can do only up to some point, and then it gets into hypothermia mode. On the other end, when it cannot have any more evaporative heat loss, then the core temperature starts to increase and it gets into the hyperthermia mode. So all that are active processes, as opposed to what we have been studying, that's more like it's a passive heat conduction with heat generation. So here just a little bit more details of thermoregulation. As I said, it is an active process. So we can divide the animal kingdom into cold-blooded and warm-blooded. So here in this example, um, the human human is the warm-blooded, whereas the frog is the cold-blooded. So there are fishes and reptiles that are cold-blooded, so they don't regulate. So warm-blooded, how do they regulate? We can divide the mechanisms by which they regulate to behavioral, like moving to a shade, or curling up. So in both cases, they reduce the heat loss or heat gain, in this case by reducing surface area, and in this case by simply reducing the heat loss or heat gain. So those are behavioral, that is done by warm-blooded animal. Then there are autonomic. The body does it by itself, and that one possibility is heat production, for example by shivering or increased metabolic heat generation, or increasing heat loss, and one of them is this non-evaporative or vasodilation, where the blood vessels near the surface, they dilate, they increase in size, so that there's more warm blood from the core flows near the body surface to be able to exchange heat more efficiently with the surroundings, and therefore increase the heat loss. The other way to increase heat loss is evaporative heat loss, or panting. Okay, so these are all the ways, the active ways that the body can thermoregulate.